Yes, Raina. How are you?
I'm good. How are you?
I'm fine. How was your weekend?
It was good. How
Okay.
yours?
My weekends are always fine. Teaching
Good.
students. So, anything new you did in school?
Right now for math, we're going into what's it called? Uh, Transition and that stuff. Translation,
Hmm.
translation, rotation, and yeah,
A reflection.
yeah. And we had a worksheet
Mm-hmm.
about it.
Mm-hmm.
Yeah,
Okay. Basically, it is covered under tessellations.
yeah.
Okay. Linear symmetry, rotational. Having a worksheet.
Yes, I have done it. 1 second, it's like a lagging. It's really good. This is the one. I was doing quite a bit of it, but then I got stuck on this
Okay.
question. It was,
87% you already completed.
yeah,
Good.
wait, I don't know why it's,
What happened?
okay. So this is about, what? Wait, they're saying they're all answered.
It's
Okay,
timed. So,
yes. In this smart lesson, we have been looking at translations and what exactly is translation?
mhm.
It's basically like signing. Oh, wait, it's another word for. And normally when shape goes up, down, left, right.
Yes, that is across X or Y axis.
Yeah.
It should be translation, not translating.
It is a question that's not saying right down. Right.
Hmm.
Okay. So it's 2 2, so after it's find it.
First is X axis, second is Y axis.
Yeah. So here's another question. Image shows a red panda space over the Gaussian face between lights, not a dimension. Okay.
It's not a translation.
Yes. It's
It
not.
is slide and then it is uh, turning through an angle, isn't it? The
Yeah.
image.
It's rotating.
It is rotating through an angle. So, translation is basically across the four quadrants, but it does not rotate. It only slides.
It is not. It is not moving Friday.
It is sliding, right? Sliding is there, but
The
rotation is also there. Check.
red panda is rotation. Yeah. Okay. So
Hmm.
yeah, friend was planning a walk to the candy store. He starts at point Z on the Kardashian below. Point Z.
He goes and get,
This
okay,
step
there is
with
Z.
by moving 14 units to the left and 15 down.
Then 15
First,
units to the right and finally 5 units up. So there is 14
okay.
units left. 14
So
units
1,
left, 15 down.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Hmm.
And then how many? Down?
Down is 15 units, right? Just
Wait a minute. See, wait, it says negative, okay, negative 7, 8. Then it's 15 down, yes. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's there.
and then
Then
how many
15 to the
units
right.
to the right? Some units to right. 14 units, 15
Like this.
units right, and 5 units up.
So it will be here. And then 5 up. 1, 2, 3, 4, 5. That's where it is.
So that
Writing of
is
the
8 and negative 2.
now on the card is the short. Okay, a shorter point could just be from here. Oh, oh,
What happened?
sorry, I was going a little. Okay, wait. It's not. Yeah. Wait, what?
What happened?
Okay, we have to go to the end. Okay, by now you should be familiar. Okay, done.
Your screen is stuck somehow.
Now it's finished.
Okay. Any more sheets?
No.
So what do we do today? Tell me.
I don't mind.
Give me a topic.
Rotation and translating and reflecting.
Okay. Basically, it's reflection and rotational symmetries. Okay. Fine. Just a easy worksheet. You learned about the order of rotation.
Um,
Yeah. Right. So I'll be sharing a screen with you. It starts from basic order of rotation to
yeah.
symmetry. There.
Okay.
The order of rotational symmetry in the following figure.
How do I show it?
No, you just need to tell.
By the order of rotation,
Hmm.
symmetry, rotation.
Order of rotational symmetry in the following figure. Usually, see when you rotate after one
Yeah.
complete cycle, the point that starts should end up at the same point. So, how many order of rotational symmetry is possible for this figure?
Um, two.
Okay, let's see.
Oh,
Any one of the following, for instance, four. There are four corners. Each one can be rotated and it moves back to the same place from where it starts. It looks the same after a partial turn. So when you look at the arms, how many arms are there? Four. Each arm is similar. Now, if arms are different, suppose we are having only two arms, then its order of rotation becomes two. But four arms over here, you rotate it by any arm, it reaches to the same position after a complete cycle. That is one. Then each arm rotates through a quarter to reach the same position. So it is four.
yeah. Okay.
Okay, here
Um,
order of
three.
rotation three. Okay, that's correct.
Um,
Number of lines of symmetry in the box. How many
four.
lines of symmetry? Four. Okay, and which are those?
Um, what do you mean by that?
Four lines of symmetry, that is agreed. Two diagonals and two across the plane. So let's say four. That is incorrect. Why?
Um, I didn't know the question, man.
The number of lines of symmetry in the box. Lines of symmetry. Line of symmetry would divide the figure into two equal halves, identical halves, right? So if it is a triangle, it divides it into centers as that two equal halves.
Um, okay.
Which of the following options shows the reflection? Reflection is just mirror image, not
Yeah.
sliding. Okay, reflection of the image above the dotted line. Let me just adjust the size for this so it fits. And there, you just need to identify the reflection.
Okay.
And that's a dog.
It will be what?
That's a dog barking.
Yeah, he gets very excited and
You
barks
have a
a lot.
you have a pet dog.
Yeah.
Which breed?
He's a terrier cross with an Irish Shorthair.
Oh, okay,
Yeah.
friendly.
It, yeah, very friendly, but he gets so excited, like
Hmm.
he wants to meet the dogs, but he doesn't like. He's very friendly to other dogs, but he gets like very excited, so he starts like barking at them to get
Hmm.
their attention.
Okay.
Yeah.
Fine. Let's get back to our question.
The question answer will be D. No, no, sorry, not D, 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 C, C, C.
C. Mirror
Oh, well,
mirror
okay.
image
Yes.
is a reflection. That line,
No,
dotted line drawn over there is a mirror. Suppose you're standing in front of the mirror.
yeah.
How do you see your reflection in the mirror? The same thing,
Oh,
that dotted
no,
line
no,
is a
no, no.
mirror.
It's A, it's A, it's A.
Okay, let's go with A and see if it is correct. You feel it's correct?
Yeah.
Okay, why you didn't choose D?
Because D has a missing one in the middle.
Okay, then why not C?
Because C
Mm-hmm.
has an extra one.
C has an extra one. Okay, and that is perfect
Mm.
explanation. How many lines of symmetry are there in the given figure?
Um,
Line of symmetry would divide it into two identical parts, two identical halves.
one.
And that is which one? Across x-axis or y-axis?
X-axis.
Yeah, across x-axis. Now how would you divide this figure into across x-axis?
Um, Wait, no, you can't do it into symmetry, so none.
Hmm. Yes. So let's see. That's correct. One would have been wrong. How many lines of symmetry?
Wait, none,
Why?
because one is cross and one is straight. They can't add up.
Hmm. Can you access the whiteboard at your end?
Yeah.
Access the whiteboard. Copy this
Okay.
image, paste it on the whiteboard.
Okay.
Just take a print screenshot, paste it on the whiteboard,
Yep.
paste it.
Wait a second. Yes.
Okay, just share your screen now. Just try and draw a line of symmetry for this figure. Just share your screen, not the whiteboard, okay?
Yes. Oh wait. Yeah. Okay. Here.
Mm-hmm. Yes, so the line of symmetry, is it possible to draw? Check.
Yeah.
You can use the line tool to draw.
Yeah. Um. You can't do this because then
Hmm.
it just
That
doesn't
way is
add
not
up.
possible. That way is not possible.
Yeah.
Can you divide it across the y-axis?
Okay. Like that.
Mm-hmm. From the center.
But can't you not go in the center?
Sorry.
I thought, oh, even I thought of the center, but I thought you couldn't go in the center.
No, you can.
No.
So, is it possible to draw a line of symmetry for this one?
Yes, with one line.
Okay, let's see. I could be distracting you, huh?
Now it's fun.
Okay, let's see. If I manage to distract you, well, that's a correct decision.
Are you good at chess?
Sorry?
Are you good at chess?
Chess. No, you don't call me good at chess because I practically never play chess. You play chess?
Uh, no, but yesterday we did play chess for
Hmm.
some reason. Cause like
Hmm.
I remember the game, so I played with my dad and my sister.
Hmm.
But yeah,
Who won?
we won.
We
Me and my
means we
sister.
means you or your
Me
dad
and
and
my
sister.
sister. No, me and my sister and my dad lost.
Okay, so it's like two heads are better than one, isn't it?
Yeah. But I don't really do much. I'm good at the start, and then at the end I get bored.
Yeah, chess is practically what we play is we know the basics only, but it has
Yeah.
a lot of moves.
Yes.
Okay, the number of lines of symmetry in the following figure.
Um. Fun.
Okay, and that is across x or y axis. Which axis?
X axis.
Okay, so let's see. One. You're just doing too good so far.
Yeah.
Mhm. Order of rotational symmetry.
Um. Eight.
Okay, great. How many lines of symmetry are there in the given figure?
One.
Hmm.
Oh. I know how the second replicator.
Okay, so there. Find the order of rotational symmetry.
Um. Two.
Two.
No, no, four, 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 four.
Four. Okay.
Yeah.
What made you change from two to four?
Because I forgot that you can also go like turn like from like down and up. I was just thinking of
Hmm.
sideways.
Okay. Two was correct answer. If you flip it, you're speaking of flipping, isn't it? If you flip it,
Oh,
you change the shape. The figure becomes inverse image of what it is. So flipping
yeah.
is not considered. It only had two. You were correct. Okay, how many lines of symmetry are there in this given figure?
Um, four,
Okay, that was smart. Which of the following letters of English alphabet has both vertical and horizontal lines of symmetry? Both vertical and horizontal lines of symmetry.
I, B,
Okay, that's great. What is the order of rotational symmetry of a square?
four,
Hmm. Great. For this one,
four.
four,
No, 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 two, two, two.
two. Okay, I go with two. How many lines of symmetry are there in the figure?
One. No, 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 none, none.
Sure.
No, none. No, one.
Either one or none.
One.
Okay, that is correct. Along the y-axis. Lines of symmetry.
One. Two.
2. Let's see if you are correct this time. Great.
Yes. Um, One.
Okay. What is the fraction of letters that have rotational symmetry?
Okay. Three out of six.
Which one are those?
Um, S, X, O.
Mhm. So I go with 4 by 6, 3 by 6, 6 by 6, 5 by 6. Which one?
3 by 6.
3 by 6. Okay. Now SPX
I said X.
NOQ. It's
Q, how's Q?
looks the same after rotation of less than 360 degrees. Less than 360 degrees, it should look similar.
Yeah.
So P is not possible, isn't it?
B.
P is not possible. It looks
Yeah.
similar only after 360 degrees. S is not possible. It looks similar after 360 degrees. X and uh, O and Q, yes, because Q is only 180 degrees. O is any. N is again 180, that is negative. And then X. So 4 are
Okay.
possible. This is getting easy.
Kinda.
Okay, I take tessellations of graph. Just a second. Identifying translations. Okay,
Okay.
then we'll go to vertical translation.
Um.
Just a second, I'll share. Okay, there. Here.
Yeah.
Okay, describe the position of the blue figure relative to the red figure.
I think that the blue figure has translated
Mm-hmm.
because the shapes are exactly the same.
Mm-hmm.
Nothing is changed besides where it's placed. So I think
Okay, only size wise they are same, not
yeah.
position wise. Here's the graph again. There.
Wait, what's the question?
Question is below.
Oh, units of the left to the left.
of A,
Hold on,
B, and C. Dash
so
units to the.
I'll
Mhm.
do the blue one first.
Yeah.
Okay.
You have to do blue one. On doing this, we see that A dash, B dash, and C dash are. It's only
Yeah.
asking for blue. It's not asking for red. Dash units to the left of ABC. That is, you're comparing from A to A dash. How many units? B to B dash and C to C dash. That is what they mean because it is just a slide.
Wait, what?
It's just sliding, isn't it?
Yeah.
So they want you to give the position as per A dash, B dash, and C dash when compared to A, B, and C. So practically, you're
So
comparing blue one to red one.
A's coordinates are -4 and 3. Then B is -7 and -1.
Hmm.
And C is 1.5, -1.5 and -1.5 and 0.5.
Hmm. That is so
And
far
then
correct. That is so far correct. We need
yeah,
we need the number of units to the left of A, B, and C. How much has it moved? See, the original triangle is ABC. It has been
okay.
moved and
But
placed at A dash, B dash, and C dash. So how many units to the left has it moved? That is, each point is moving the same number of units, isn't it? Because the size is still the same.
it has moved 8 left, and then
How many units below? 8 left and how many units below?
below
Hmm.
3 below.
3 below. 8 left and 3 below, right?
Yeah.
That is correct. Okay, now again, the same graph. The question is there. Let me just try and adjust the size. So the graph is also there.
Have they already answered it?
No. Okay. This one is already tick mark that you already answered once before, right? So we move to the second
Yeah.
one. There.
Okay.
The question is below. Find.
It is translating again.
Hmm. Okay. Have you learned about algebraic express representation of the translation? No.
I don't know.
Okay. Now here we found that the red figure is nothing but the translation. We also give the unit 6 units right and 4 units down. Okay.
Yeah.
That is that entire figure. Not
Yeah.
so if it does not change its shape or size, each point
Yeah.
moves through the same number of units. So representing the given translation algebraically, that is how you represent x moves through how many units, either right or left. Y moves how many units are either up or down. So if it is about algebraic representation is x plus so much and y plus, as you
Yeah.
would represent it in the form of x and y axis. That is what it is called as algebraic representation. Okay, is this clear? Yes.
Yeah.
Okay. Here,
Um.
read the question. From 3a, you follow to 3b.
Yeah. Is
Let me just adjust the size. There.
we're still on the last question for me.
Sorry?
It's a little glitching. Oh wait, now okay, now it's okay. Now it's okay.
There. That's a
Okay.
question.
To do this, let's observe how the coordinates of the is related to the
Don't miss part
okay.
3a. Don't miss part 3a. It starts from 3a goes to 3b. 3A is already only tick mark. Some instruction is given over there. Based on that,
Okay.
you work out 3B.
Under certain translation, the image of the point, level 4, the point. How can we move to it? Oh, the x coordinate of
The x coordinate of 3 and negative 5 is dash. That of
uh,
negative 4 and 2.
7
Mhm. And the y coordinate,
is 7,
7 and 7.
like 7 more and then 7 less.
So plus 7 and minus 7. Okay. Here.
Okay,
Representing algebraically.
so that could be x.
X is, see the instructions are given over there. Its x coordinate is 7 more than that of negative 4 and 2. Y coordinate is
Mm,
7 less than that of negative 4 and 2.
right.
So in terms of x and y, algebraically how can we represent it?
Oh, with the signs like like the shark signs, sharking.
More and less, how do we represent it? Not that sharp thing.
Oh,
Plus and minus.
oh, okay.
That sharp thing is less than or greater than sign. Not using that.
Uh, I'm not, I don't know.
Okay, 7 more, x coordinate 7 more than negative 4 and 2.
Yeah,
Y coordinate 7 less than negative 4 and 2. Now in negative 4 and 2, x is negative 4, y is 2.
yeah,
So 7 more than x coordinate and 7 less than y coordinate.
okay.
X plus 7, y minus 7. 7 more, 7 less. You are not familiar with algebraic representations. So far, they haven't started algebraic representation because before you start with the translation, reflection, and rotation, at least first thing you learn is to identify the position of a point, isn't it?
Yeah,
And then you
because,
learn, yes, and then you learn how it was moving across the x or y axis, giving its new coordinates.
yeah,
And then you learn the differences between how much it has covered from moving from point A to A dash, right? So when you're learning that moving point from A to A dash, that is either it is moving to the left or right, up or down. So depending on that, it is either more than or less than.
yeah,
Yes, this one, if image of A is 1 and 3, under certain translation, A dash is negative 1 and 1.
um,
A is 1 and 3. A dash is
yeah,
negative 1 and 1.
yeah,
Find the coordinates of the images of B, 2 and 4, C, negative 2 and 2 under the same translation. So A, B, and C, you are given A dash, you need B dash and C dash under the same translation.
okay.
You can draw a rough figure in the notebook.
I don't know what it is.
Okay, see on the graph, if you plot A, 1 and 3,
Yes.
let's go over here. Let's take, uh, just give me 1 minute. Okay, I'll be sharing the screen with you. What are you doing?
Everything.
Okay, there. Let's take a graph there. Okay, now what I do is I just draw the four coordinates over here. This is 1, 2, 3. So the coordinates for A is what? What is given to us? A is 1 and 3, right?
Yes.
Okay, just a second with my keyboard there. A is 1 and 3. So it would be here. This is A. Okay, then the next one given to us is B is 2 and 4. We plot B is 2 and 4 would be here. And then the next one is C is negative 2 and 2.
Yeah.
Negative 2 and 2 would be here. So this is A, this is B, and this is C. Okay. Now for our convenience, let's just try and join these lines from A to B and from B to C. There. Okay. That is the figure. It's a triangle A, B, and C. Now over here, they give us the new coordinates for A dash. A dash is negative 1 and 1. Negative 1 and 1 is over here. So practically this is A dash.
Negative one and one is in there.
Negative 1 and 1, sorry. Negative 1 and 1 is over here. Yes.
Yeah.
Okay. So this is A dash. Now from here, if you need the coordinate for B dash and C dash, so A moves from 1 to negative 1
Yeah.
and from 3 to 1. That is y
Yeah.
axis. Okay. So B moves from 2 to where? X axis, and 4 to where? Y axis.
Yeah.
Yes. What happened?
Nothing.
A moves 1, 2. How many points down does it move? 1, 2, and 1, 2. 2 down and 2 left. So B also moves 2 down and 2 left. That is 1, 2, 1, and 2. B is going to be here. And C
Okay.
moves 2 down, 1. 2 and 2 left. C is going to be here. So
Here.
when you draw this, it is going to be this and this and this. This is A dash, this is B dash, and this is C dash.
Yeah.
Exactly.
Yeah.
Okay. There.
Yeah.
I'll be sharing the screen. That's a cricket field represented on a coordinate plane.
Yeah.
Points are marked P and R.
Yeah.
Assume that a batsman and a fielder are located at point P and R. Now, when the batsman hits a ball up into the air, it lands at point Q. Q is
Yeah.
marked over there. Represent the following. Translation of the ball from point P to point Q.
It will be
Mhm.
5 right and then 3 up.
5 right, 3 up. Okay. A possible path that the fielder located at R can take to catch the ball.
Was it right?
Sir, yeah, that's correct.
Okay.
The possible path that the fielder located at point R can take to catch the ball.
Um, Sorry.
R is marked over there. He needs to reach Q.
5 left and
Hmm
4 down.
He needs to reach till Q. Q is marked in 1. 5
Yeah.
left. 5 left you said is correct. How much down? Not
4.
not 4, not 4. Count back again.
Oh, the play. Yeah, 5.
5, not 4. Okay.
Yeah.
Now here again the figure given there. Based on the above figure, a possible path that fielder takes to reach to catch the ball is what would be the x and y axis? 5 and
So it will be
x and y axis you need to give
okay.
for the possible path that fielder can take to catch the ball.
Either okay, so it will be
Hmm
x plus 5 and then y plus 5. No, negative minus 5.
hmm X minus 5 and y minus 5.
What?
X minus 5 and y minus 5. Why? He's moving down from 5 to 0. That is negative. He's moving x from 6 to 0. That is negative. That is less. That's why it's negative.
Okay.
Okay. Functions. We don't need, you don't have functions. Let's not go for functions right now. Just identifying translation between two figures. Okay. There. Just simple two-dimensional figures. Translations. Okay, that's not the question. Okay. The following simulation shows triangle ABC which can be moved around the coordinate plane using
Yeah.
a given sliders.
Yeah.
So we have ABC as a triangle. Okay, just
Yeah.
for our simulation purpose, we move it to the units here. Okay, that is the logic that you already know.
Yeah.
Fine. Now let's go with the set of questions. Those are the coordinates of triangle ABC.
Okay. So 0, 1 will now go to 0, 3.
Hmm.
And then um, 3 down will be, so then it will go to, oh sorry, no.
AU to
It will
two
go to
units to
3,
the
1.
right.
Yeah, it will go 3, 1. And then it will go 3, 4.
Hmm. So the new coordinates of A dash, B dash, and C dash are going to be
3, 4.
for all 3 points. They need coordinates for all 3 points, isn't it? It's a
Okay.
triangle. Coordinates for A, B, and C are given over there. Two
Yeah.
units right and 3 units down. This whole figure moves
So,
2 units right, 3 units down. We need new coordinates for A dash, B dash, and C dash. For A dash is
yeah.
how much?
So, um, sorry. It will be
2 and how much? 2 to the
2
right. From 0,
and
2 to the right will reach till 2. X
negative
coordinate
2.
is 2. To the right.
Yeah, negative 2. It's 3 units down.
3 units down is first you say the x axis, isn't it? Then you say the y axis.
Yeah,
Okay, so x is
so it
going to
will
be
be
how
2.
much? X will be 2
2
and y,
negative 2. 2
okay,
negative 2.
2 and negative 2, correct. And what about b? From negative to negative
B
1
will
to
be,
same 2 units right, 3
it will
units
be
down.
0. It will be 0 and negative 4.
Okay, and c?
Um, 5
Mm-hmm.
and negative 4.
Okay, correct. Let's not take algebraic expressions because that is still not covered for you. All algebraics over here.
Oh, the answers I've shown.
Yeah. Okay. I'm sure you didn't see the answers for this.
Okay. So it is x minus 5
Mm-hmm.
and y plus 4.
Okay. Correct. Next.
And then it will be x plus 3,
Mm-hmm.
and then y minus 2.
Okay. Then
Um, I'm on the sixth one, right?
yeah.
Yeah. So then x minus 6,
Mm-hmm.
and then y minus 7,
Okay. Then last one.
x plus 1,
Mm-hmm.
and y plus 12.
Okay.
Were they right?
Yes. Okay. Now you understand the logic of see, algebraic representation is nothing but it's just only thing. The difference is there is no figure over there. When a figure is given, it's easy to
Yeah.
imagine. Now, what if the figure is not given? Just the coordinates are given. Still, you need to keep two things in mind. One is the x-axis, one is the y-axis. How much is it moving along the x-axis? If it is going towards the left, it is always negative, minus, or less. If it is going towards the right, it is always positive or plus. Same thing for y-axis. If it is going up, it is plus. If it is going down, it is minus. Now, if I draw the figure for you on the graph paper, you still use
Yeah.
the same logic, isn't it? It says move 3 units to the left. You move it 3 units to the left, but its coordinates are always minus, isn't it? If you move 3
Yeah.
units to the right, its coordinates are always added or plus. Same thing when it is moving
Yeah.
up, the y coordinates are always plus. If it is moving down, the y coordinates are minus. So, algebraic representation is working out the new coordinates after translation without drawing the figure. Is that clear? So, it is just about
Yeah.
x either less than or more than, y either less than or more than the given number of units. That is the only difference. So what you're doing right
Yeah.
now in your class is you're getting a figure and you simply move it. What I did was I did not give the figure, there is only coordinates and you're just moving a point. So
Yeah.
still it is the same. Is that clear?
Yes. Yeah.
Okay, apart from this rotation, how many possible rotations? So far you studied clockwise, anti-clockwise both.
Yeah.
Okay.